Okay, today we're going to go over CC1 5.1.3 review and preview. Problem 24 starts with write each of the mixed numbers below as a fraction greater than 1 and write each of the fractions greater than 1 as a mixed number. Include a diagram to explain each answer. So for part A, I'm looking at 4 and 1/3. So I know that my diagram is going to be split into thirds because my denominator is 3. So there's 1 whole, 2, 3, 4, and then it was and 1/3. So I shaded in one piece. If I go and look at all my shaded pieces, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 thirds. Okay, we do have to include the diagram, but remember, I can check my answer. I can say 4 times 3 is 12, plus 1 is 13. Keep my denominator. That's how I know I'm right. 15 fourths. So I'm looking at fourths. So there's 1, 2, 3, 4. I apologize for that. So I have 1, 2, 3, 4 fourths. 5, 6, 7, 8. 9, 10, 11, 12, 13, 14, 15. So if I look at this, I have 3 wholes with 3 out of 4 left. Again, I can check this. 4 goes into 15. Well, it's not quite to 16, so it's not 4 times, it's 3 times. And 3 times 4 is 12, and I have 3 left over. Part C, 3 and 1/2. I can, again, use diagram. I like to use these diagrams. Your diagram could look a little bit different than mine. I could use circles instead, right? And split them into halves. So there's 1, 2. There's 1 hole, 2 holes, 3 holes, and 1 left over. That 1/2. So it's 1, 2, 3, 4, 5, 6, 7 halves. And again, I can check it. 3 times 2 is 6, plus 1 is 7, and I keep my denominator the same. 15 eighths. I could use something like Grant's method that we learned about yesterday, and split a box into 8 pieces. Okay. I know they're not perfectly straight, but I need to shade in 15 of them. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, so I have 1 hole and 7 out of 8 in my other box, in this box here. Again, I can check it. 8 goes into 15 1 time. It's not quite to 16. So 8 goes into 16 2 times. So 8 goes into 15 1 time, and I have 7 left over. Problem 25, we're calculating each of the following parts of parts. I do not need to use a diagram at this point. we have to remember that to multiply fractions, we go straight across. So 2 times 3 is 6. 3 times 7 is 21. I can simplify, okay? I see that if I have 6 and 21, my least common or my greatest common factor of 6 and 21 is going to be 3. 6 divided by 3 is 2. 21 divided by 3 is 7. So I can use a giant 1 to help me. 6 divided by 3 is 2. 21 divided by 3 is 7. Going to do the same thing for part B. 1/2 of 3/5. 1 times 3 is 3. 2 times 5 is 10. It is simplified as much as I can get. Okay. Problem 26. We're multiplying each pair of numbers below. Okay, so part A, 68 times 100. Well, my decimal moves over. Part B, I'm multiplying 68 hundredths by 100. My answer is going to be 68 because my decimal point moves over. 6 and 8 tenths times 1,000. 68,000 or 6,800, 6,800, sorry. Okay. What is happening to the decimal point in each problem A through C? The decimal point is moving to the right. I can see this here. I went from 68. Okay, my decimal point's here. I multiplied by 100. My decimal point moved 2 places over to make 6,800. 0 and 68 hundredths times 100. Because it's 100, I move it 2 places for those zeros, and I ended up with 68. 6 and 8 tenths times 1,000. Well, there's 3 zeros, so I move it 3 spaces. 1, 2, 3. And I end up with 6,800. Okay, on the back side. On the graph paper, draw a rectangle with a width of 6 centimeters and a height of 8 centimeters. So my height is 8. 1, 2, 3, 4, 5, 6, 7, 8. My width is 6. 3, 6. I'm going to include my labels. Okay, part A says to draw a similar rectangle that is enlarged to 300%. Remember that percents are fractions out of 100. 300 over 100 or 300 divided by 100 is 3. I'm multiplying each side by 3. My new rectangle is going to be 8 times 3 is 24. So 24 high. Okay, and my 6 times 3 is 18. And I'm going to label that with part A so that I know. Okay, part B says to draw a similar rectangle with lengths that are 2/3, 2 to 3 of the original lengths. Well, what I can do is I can take 8 and multiply it by that ratio. And remember, if I do that, my whole number, 8 goes to 8 over 1. So it would be 16 thirds. Okay, well, I have to do some math. I have to make it into a fraction, a mixed fraction. So 3 goes into 16 5 times. 3 times 5 is 15. So I'll have 1 left over. Okay, and I do that with my other side length. So 6 times 2/3. 6 is really 6 over 1, 6 divided by 1. 6 times 2 is 12. 3 times 1 is 3. 12 divided by 3 is 4. So my new lengths, okay, where I see the 8, it's going to be 5 1/3. So my height, 1, 2, 3, 4, 5, and about 1/3. Okay, I am labeling it. And then it goes 4 over. 1, 2, 3, 4. And I put my labels. Okay, last problem. Problem number 28. Sophie claims that whenever she increases the perimeter of a rectangle, its area increases. She showed the rectangle below and said, well, if I make the base twice as long, the area increases. Is her statement for this figure correct? I forgot, there's a typo. Okay, so we need to draw a diagram of the new rectangle she described and explain whether the area is greater or less than the rectangle at right. So she doubled the base. So double 6 is 12. Her height is the same. Okay, so that's her new rectangle. She says the area changed. So the area here is 6 times 3, which is 18 centimeters squared. The area for this new rectangle is 12 times 3, which is 36 centimeters squared. Yes, she is correct. The area increased. Now, part B asks us, well, is her claim about the relationship of area and perimeter correct for all figures? For example, is there any way that she could have a rectangle with a greater perimeter than the figure in part A, but with the same area? Give examples and explain your reasoning. So, I'm going to think of different combinations of numbers that could get me the same area. Okay, so 6 times 3 is 1. We've already used that. I could do 1 times 18. A 1 centimeter by 18 centimeter rectangle. So the area is going to be 18 centimeters squared. But my perimeter, well, 1 plus 18 is 19. Plus 19. 9 plus 9 is 18. 1 plus 1 plus 1 is 38. So the perimeter is 38. Okay, now it has the same area. I don't know about perimeter because I need to add it here. So the perimeter here is 3 plus 6, which is 9, plus 3 plus 6, which is 9. That means it's 18. So the perimeter's changed. I could try it again. We could do 9 and 2. My area is going to be 18. But my perimeter all of a sudden is going to change again. So I have 9 plus 2, which is 11, plus 9 plus 2, which is 11, so it's 22. So her claim is incorrect. Okay, you can have a rectangle that's perimeter increases while the area stays the same. Okay, for example, our work over here. As always, if you have any questions, please make sure you come and ask.